This is lesson 12. We are going to continue to solve questions about the exponential equations. Here, 3 to the power of 2x minus 3 to the power of x is equal to 72, and this is a similar question to that one. What is the common thing about both of the question? If you say, we can say like this: if we have 5 to the power of x, then here 5 to the power of x, if we say t, then 5 to the power of x to the power of 2 is going to be equal to t squared. You know this one. And this can be written like 5 to the power of 2x is equal to t squared. So here the term, this is t squared, and this is going to be t. Let's find this one. 3 to the power of x, 3 to the power of x to the power of 2 minus 3 to the power of x, if it's equal to 72. And if I substitute t by 3 to the power of x, this is going to be equal to t square and minus t is equal to 72. T square minus t minus 72 is equal to 0. It's going to be t and t. You may factorize. 72 can be written as 9 times 8, and it should be minus 9 because here it should be minus 9 because the t value here negative. The greater one must be minus 9. Minus 9t plus 8t, sum is minus t. Okay, t minus 9 times t plus 8 is equal to 0, and t is equal to 9, and t is equal to minus 8. It means that 3 to the power of x is equal to 9. X must be, you know that one, it's equal to 2. And here 3 to the power of x is equal to minus 8. When you say, we should write here no solution, because we cannot solve this part with logarithm. Also, if 3 to the power of x is equal to 8, we have solution for this one. X is equal to logarithm base 3, 8. But when it is negative, the number written here, if it is negative, we don't have solution. If it is positive, we will have solution. Okay. For the second one, 4 to the power of x can be written like 2 to the power of 2 to the power of x. Then it can be equal to 2 to the power of x to the power of 2 also. So instead of 4 to the power of x, I'm going to write 2 to the power of x to the power of 2 minus 2 to the power of x times 2 to the power of 4 plus 48. It's going to be equal to 0. 2 to the power of 2, if we say 2 to the power of x is equal to t, then this is going to be t squared minus t times 16 and plus 48 is going to be equal to 0. This is going to be t squared minus 16t plus 48 is going to be equal to 0. T squared minus 12 and minus 4, it seems. Minus 12 times minus 4 is going to be equal to 48, and the sum is minus 16. So the factorization t minus 12 times t minus 4 is going to be equal to 0. t1 is equal to 12, t2 is equal to 4. If 2 to the power of x is equal to 12, and here the second solution, 2 to the power of x is equal to 4, x, it should be none of the power of 2 is equal to 12. That's why it's going to be equal to logarithm base 2 and logarithm base 2, 12. And here x, it should be equal to there's no need to solve this one by logarithm. 2 to the power of x is equal to 2 to the power of x is going to be equal to 2 to the power of 2, so x is equal to 2. So there are two solutions here, logarithm base 2, 12, and x is equal to 2. It's going to be. For the first one, as you remember, we have only one solution, and that's equal to 2. Yes. If we continue with the similar questions, here this question and this question is different. Here the powers with 3 to the power of 2x it was, but here both of them 2 to the power of x, 2 to the power of x, and here this is 5 to the power of x and 5 to the power of x. So I'm going to get 2 to the power of x bracket for this one, 2 to the power of 4 plus 2 to the power of x times 2 to the power of 2 is equal to 5 to the power of x times 5 plus 5 to the power of x times 3. Actually 2 to the power of x times this is 16 plus 2 to the power of x times 4 is equal to 5 to the power of x times, when you get 5 to the power of x bracket, you should write the others here in bracket, in parentheses. It's going to be like this. Then 2 to the power of x times 16 plus 4 is equal to 5 to the power of x times 8, and 2 to the power of x times 20 is equal to 5 to the power of x times 8. It's going to be. And now they're in multiplication form with the coefficients here. So I can write like this: 2 to the power of x over 5 to the power of x, I wrote this one, is equal to 8 over 20. So if I simplify these two, 8 over 20, they are both divisible by 2. That's going to be equal to 2 over 5. And 2 over 5 to the power of x, 2 over 5 to the power of x is equal to 2 over 5. And here x must be equal to 1, as you understand. This is the solution of the first one. Here, this is A. And if we continue with the B, 4 to the power of x we have here, and this is minus, and plus 2 to the power of 2x minus 1 is going to be equal to 3 to the power of x minus 1 over 2 plus 3 to the power of, pardon, this is plus, this should be on the other side, it should be plus. So x minus 1 over 2 is going to be, and here it's obvious 2 to the power of 2x is equal to 4 to the power of x. 4 to the power of x times 1 plus 4 to the power of x times 2 to the power of minus 1. And this is 3 to the power of x plus 3 to the power of x to the power of 1 over 2, 3 to the power of 1 over 2 plus 3 to the power of x times 3 to the power of minus 1 over 2 it's going to be. And this is going to be 4 to the power of x times 1 plus 4 to the power of x times 1 over 2, the power is negative, and this is going to be equal to 3 to the power of x times root 3. When the power is rational number, it should be 1 over 2 here, plus 3 to the power of x times 1 over root 3. 1 over root 3 it should be, because here the expression is negative and rational together. So 4 to the power of x bracket, if we get, it's going to be equal to the rest is going to be equal to 4 to the power of x 1 plus 1 over 2 is equal to 3 to the power of x bracket, if we get root 3 plus 1 over root 3 it's going to be, and 2 times 1 plus 1 is going to be equal to 4 to the power of x times 3 over 2 is equal to 3 to the power of x times 3 times 3 is going to be equal to root 3 times root 3 is equal to 3 plus 1 is equal to 4. So 4 over root 3 it's going to be. We have to send the terms to one side. 4 to the power of x and 3 to the power of x. If I send completely the term to the other side, 4 to the power of x over 3 to the power of x it's going to be is equal to, this one goes up, this one goes down, and it's going to be 4 times 2 over 3 times root 3 is going to be. And if I write them in common bracket here, I'm going to rewrite this one, 4 over 3 to the power of x is going to be equal to, or let me continue to down. Here I can continue like this. 4 over 3 to the power of x, it's going to be equal to 8 over 3 root 3, it's going to be. Then here the power is only 1, it's going to be equal to logarithm base. This power comes, base comes as logarithmic base, 4 over 3, 8 over 3 root 3, it's going to be. This is the value of x. Is going to be. For this question, 9 to the power of x, 4 to the power of x, 6 to the power of x we have, they are all related numbers. 3 to the power of 2 to the power of x, you know, it's equal to 9 to the power of x. This is 9 to the power of x, and it can be written like 3 to the power of x to the power of 2, because we have here 6 to the power of x. 6 to the power of x can be written as 3 times 2 to the power of x, and that's equal to 3 to the power of x times 2 to the power of x. And with respect to all these are, 4 to the power of x can be written as 4 to the power of 2 to the power of, 2 to the power of 2 to the power of x, and it's going to be equal to 2 to the power of x to the power of 2. So this is going to be equal to 3 to the power of x to the power of 2 and plus 2 to the power of x to the power of 2 and 5 over 2 times 3 to the power of x times 2 to the power of x, it's going to be. And if I say 3 to the power of x is equal to a and 2 to the power of x is equal to b, then here it's going to be a squared plus b squared is going to be equal to 5 over 2 times ab. So 2a squared plus 2b squared I multiply by is equal to 5ab, and 2a squared minus 5ab minus 2b squared, it's going to be equal to 0. Here this is quadratic equation and this is plus, sorry. And this is quadratic equation, 2a and a we can factorize. Here this one minus 2a and minus 2b and minus b, it can be minus 2ab, no, minus b, and we are going to factorize like minus b and minus 2b, and it's going to be equal to minus 4a minus ab is going to be equal to 2a minus b times 2a minus b is equal to 0. So 2a minus b is equal to 0, 2a is equal to b, and the second one 3a, pardon, not 3a, a minus b is equal to 0, a minus b is equal to 0, a is equal to b. 2a minus b, if it is equal to 0, it means that 2 times 3x is equal to 2 to the power of x, and it can be written like this: 3 to the power of x over 2 to the power of x is equal to 1 over 2. And if we write the powers here, 3 to the power of x, 3 over 2 to the power of x, it's going to be equal to 1 over 2. Then this goes down as a logarithmic base, and this falls down like it falls down. I said 3 over 2, 1 over 2, it's going to be. If a is equal to b, it means that 3 to the power of x is equal to 2 to the power of x. Normally this is possible only for 0, and 3 to the power of x over 2 to the power of x is going to be equal to 1. 3 over 2 to the power of x is going to be equal to 1, and logarithm base 3 over 2, 1 is going to be equal to x. And when the base, argument is 1, it means that it is equal to 0. This expression is 0, so x is equal to 0.